Assalamu alaikum everyone. My name is Basit Ismail from Department of Computer Science. Today the topic that we are going to learn about is pointers from computer programming course with the course title with the course code 6900. So the introduction, what are pointers? Pointers are basically variables. We have gone over different types of variables in C++ language, different types of variables, right? So we have variables like variable types like integers and strings and characters, and also we have Boolean. The complete I'm saying Boolean, you might not have heard it said from me before, but it is the complete form of bool, which I have been saying since the first lecture. Okay, so Boolean, bool, character, string, int, all of these take certain memory in the certain memory in your RAM. Okay, so pointer is another special type of variable that stores the memory address of another variable. All of these will be stored in the RAM. All of these will be stored in the memory. So the address of these will also be stored. Address of these will also be used during certain initializations in programs. For example, if we have a variable and suppose we declared int x equal to 5, x will be stored over here and it will have a certain address. There are certain reasons and there are certain times when we have to use this particular address. We will see when this address is used. So to save the address of this particular variable, we have to define a new type of a variable, new variable. Okay. This variable cannot, this data cannot be initialized in integers or strings or other variables. So it has to be initialized in a new type of variable, which are called pointers. So it stores the memory of address of another variable as its value. So in a pointer, you store the memory address of another variable, and then a pointer variable points to the data type like int of the same type and is created with the static operator or a static operator. So what does that mean? It means that if you have an int data, you have to create pointer of int type. Okay. So here we have been given a couple of examples of different types of pointers. First, we have two different pointers, each pointing to different variables, and then we have a pointer of character type, which is pointed to which is to be pointing towards a character variable. Okay, so if we declare a string of with a variable name food and equal it to a pizza, we can use the string type of pointer to get the address of that particular food. So here it has declared a string food and that is equal to pizza. We are just outputting the value of food. Here pizza will get printed. Okay, and then we can get the address of the variable by using AND operator. This is called AND operator. And then we can also print the address. Here, for example, the address is 0x60FED4. Okay. And then it says a pointer, however, is a variable that stores a memory address at its value. So it is the repetition that a pointer is just a variable for storing memory as memory storage. Okay. A pointer variable points to data type like int or string of the same type and is created with the AND operator. So this is just repetition that you have to use a static whenever you declare a pointer. For example, I am declaring a pointer of integer type. This is the data type. This is the sign for showing that it is a pointer. This is the name of the variable. So this pointer will point to a data type of int type, only int type, not character, not string. Okay, so in the next slide, we are just going over a bit of more programming related to pointers. So we have declared pizza to be equal to food, and then we are giving the address of the food to in the pointer. And if we print food, we get the value of pizza. If we print and food, then we get the address. And if we get PTR, if we print PTR, we get the address. Okay, because PTR has been equal to and of what? And of food. So That's how it works. You have to memorize this particular syntax and also this syntax for the usage of pointers. Okay, so declaration of pointers. Declaration of pointers is just how do you declare a pointer before using it. So there are a couple of ways of declaring a pointers, namely 3. The first way is you combine the static with the data type. The second way is you combine the static with the variable name, and third is you leave the static alone and there is space between the data type and the variable name. So okay, so pointer increment, what does it means by pointer increment? For example, we have a pointer which points to address of 45. What will ptr plus plus mean? Because in the case of normal variables, if we had an integer, for example, if we had an integer x equal to 4, x plus plus would have meant increasing x equal to x plus 1. So x would have become 5. But in the case of ptr plus plus, what would happen? So it explains pointer moves to the next int position as if it was an array. So what happens is that when you add plus plus to it, so it will move 4 memory locations, because the pointer is of int type. If the pointer is of character type, then by doing plus plus to the pointer, it will move plus 1 byte. Okay. So pointer moves to the next int position as if it was an array. So there is both the usage of decrement and increment, and also post increment and pre increment. This is post increment, this is pre increment. So post increment and pre increment just works the way I have already explained in previous lectures, wherein if you post increment, then the value is first printed and then changed, and if you do the pre increment, then the value is changed first and then printed. So there is another thing which you have to understand regarding pointer is that all the 3 following cases are same. They increment the value of the variable that the pointer p points to. However, if you are just using the pointer name, then memory will move, memory addresses will move. However, if you are using not only the name of the pointer but also the static sign as well, then the value of the pointer will move as well. Then the value in the pointer will change. Value in the pointer will change. Same is the case with this syntax, and these are just different ways of declaring same thing. Okay, so you can use brackets over here, brackets over there. Then this is just the first way, this is the second way, this is the third way. Okay, so direct and indirect access, because pointers give us the memory of a particular variable. Also, for example, if we had name here, Ali, and this has an address of 56, 0f56 dfd, okay, for example, like that. So we can take and a pointer ptr s points to it, ptr s is pointing to it. So what will happen? Is that we can use pointer to access this variable, we can use the variable name to access this variable. So how will we use a pointer to access the variable? We are just going to see the code of it. We have declared an integer a equal to 5, and we have given the address of a in the pointer. So if we write ptr, it will give us print, give us the address of the pointer, give the address of the variable. If we write static ptr, it will indirectly get the value at the memory address, So that is what is happening when we are using direct access. We are using the variable name. When we are using static ptr, then we are indirectly using the value of that particular pointer. Okay, indirectly using that variable. That's it. I have already explained all of this in previous programs, so you might go and reference them if you do not understand what these direct is and what int main is and what return 0 is doing. Okay, so pointers can also be used with arrays. What is an array? Array is just like a variable that stores other variables. For detail, you might refer to the unit number 5, which is on arrays in CP, if you do not completely understand how arrays work. So variable that stores other variables. So if we had an array of integer type with 4 size, it means that it would have 4 variables. For example, it would have 7 here, 8 here, 9 here, and 10 here. And supposedly this had the memory address of 0 into x56. So this would be 0 into x60, this would be 64, this would be 68, 0 into 0 into. Yeah, like that. Okay. So if we print, if we put the array into the loop and then print the value of that array using the address, then we would get all of these addresses. We'll print all of these addresses. And if we similarly declare an array of 5 variables and then point the second variable by using a pointer, then we will be accessing the second variable. Here it has pointed the third variable because in the index it has used second. So what does second mean? Second comes from 0, 1 to referring to the indices of the variables. So here it is, the pointer is pointing towards the address, or the pointer is pointing toward the second cell in the indices, which is actually the third value in the array. So it will just print out the value. If we print static PTR, we will get 3. If we do static PTR plus 1, we would get 4. If we do static PTR minus 1, we would get 2. So that is how this particular thing with pointers with arrays works. Okay. So if we have we should go over the address once more in a more simpler form of working of pointers with arrays. So we have declared a simple array and we have given the address of the first variable of the first index of the variable array ARR to be equal to the pointer. So if when we have declared it like so, then the array name will be treated as a pointer to the 0th element of the array. If the address of the array starts from 1000, then PTR will be equal to 1000. Each element will have its own address as 1004 with 4 bytes added to a previous. So the next element would have address 1004 and then so on and so forth. Okay. So what will we get if we try to print different things regarding array and pointer? If we just see out ARR, you would get 1000 because the array variable is itself a pointer, and we have used another pointer to point to the first memory location or the first index of the array. If we print PTR, we would get the same thing. If we print ARR plus 1, we would get 1004, the next memory address, and again the next memory address. If we print static ARR1, we would get 1 and 2. And if we write ARR plus 2 equal to, what would we get? What should we be getting? We should be getting 3. Okay, because it would be moving 3 memory locations. Similarly, if we print PTR plus 1, we would get 1004, 1008. If we dereference that, by dereferencing, what does it mean to dereference? When you have the address of a variable in a pointer and you use the static alongside with the pointer, then you are dereferencing that variable. Dereferencing variable. So if you do the dereferencing operator, then you would get the first value because PTR has stored 1000 and 1000 has 0. So if we do PTR plus 1 and then dereference it, then we would get the value of 2 because 2 is the value that is present on the second memory address. So the next thing is pointer arithmetic. We have already gone over the normal arithmetic. For example, if we had a variable int x equal to 5 and we did x equal to x plus 1 or x plus plus, these two things were equivalent to each other. X plus plus is equal to x plus 1. So both of these things are equal to. So this is basic addition, and it can also be subtraction, it can also be multiplication, and can also be division or division like this. Okay, so similar things can be done with the pointers as well. Pointer arithmetic is that branch of concepts which deals with addition, subtraction, multiplication and division of pointers. So we will go over these functions or these operators one by one. So let us consider a pointer which has an integer, which is an integer pointer which points to the address 1000. What would happen, assuming 32-bit integers, what would happen if we perform a certain operation on the pointer? If we do PTR plus plus, what would happen? It would do this, PTR equal to PTR plus 1. And what does PTR plus 1 means? We have gone over it in the previous slides. What does that mean? It means it would just add 1000 plus 4. where does the 4 is coming from? It is coming from int size. What is the int size? Int size is 4 bytes. So it will add 4 bytes to the memory address, and the value of PTR will now become 1004. Okay. So after the next here it is just explaining how this operation is executed. So if the operation is executed, we will get the value of 1004. It will point to the next integer location, and because it is an integer type of a pointer, if we had a variable 4 here and 5 here, and this had the memory address of 4, then the 1000, and this would have the memory address of 4, because it would take, this whole chunk would take 4 bytes. So when we do PTR plus 1 or PTR plus plus, then it would add 1000 plus 4, and we would go to 1000 plus 4. We would go over there. Okay. So this operation will move to the pointer to the next memory location without impacting the actual value of the memory location. So it does not change the actual memory location. The memory location is not getting changed. It is just moving or traversal. If PTR points to the character whose address is 1000, then it will, above operation will point to the 1001. So this is really simple, because in the case of integers we use 4 bytes. So PTR plus plus means 4 bytes movement. In case of character, it is 1 byte movement. In case of double, it is 8 byte movement. This is not something magical. It is just working on the basis of how many bytes an operator or a variable is using in the memory. Double, because double use 8 bytes in the memory. So when you use plus plus operator or increment operator on a double type of a pointer, then it moves 8 memory locations in the memory, or 8 bytes in the memory. Okay. So pointer arithmetic is used to traverse the pointer to a certain memory location in the next memory location. So you can use pointers to move the pointer from one memory location to another memory location. Supposedly we had declared the pointer int static PTR equal to and x. So PTR plus n, what would that mean? It would mean adding n to the actual value of PTR. For example, PTR was 1000 and we are adding 4 to it. So what would happen in actuality? It would not just add plus 4 to it, it would add actually 4 plus 4 plus 4 plus 16. It would add 16 to it. So it would go over 1016. So 1016 will be the answer. So you have to understand, when we add 1 to it, it actually adds 4 to the memory location. When we add 4 to the memory location or memory address, then it goes 16 memory locations. So you have to understand this basic differentiation. Okay. So n is the number of locations. Here it is clearly explaining, when we add when we do this operation PTR plus n, we are actually adding memory locations, and each memory location or each memory number of locations would have a certain bytes in the memory. So if it was an integer type of a pointer, it would take 4 bytes. So 4 memory locations would mean 4 into 4 into 16 bytes. So it would move 16 memory locations. So you have to understand this. Okay. So if we do the opposite of it, what would happen? It would just subtract those memory locations from the pointer. So if we are to do 1000 minus 4, it would subtract 16 from 1000, and what would the value become? 984. Okay. So it would go over to the 984 memory location. What would happen? So what would happen if we minus a pointer from another pointer? So it would just minus the value of 2 pointers and then divide by the scale. So what would happen? It would happen, supposedly we minus 1010 from 1016. What would happen? It would just get us the value of 6, because we do not have a variable type of 6. So this is not a valid signature. So we would get, instead we would use 1018 and 1010. So divided by 4, we would move 2 memory locations. Okay. PTR, suppose we had 2 pointers PTR1 and PTR2. PTR1 minus PTR2 will give us this number of memory locations between these addresses. So it will give us the number of memory locations between these addresses. For example, in the case of 1018 and 1010, if these were both integer type of pointers, then it would give us 2 memory locations, because each integer takes 4 bytes in the memory. So 4 into 2 equal to 8 bytes, and 8 is equal to 4 into 2. So that 2 tells us the number of locations, 4 bytes. Okay. So it has just explained over here with a different example. You can go over it. Okay. So scale factor of the pointer. This is I have already explained what scale factor means in different words. However, we would just go over it formally. So what is the scale factor? Scale factor is the size of the data type of the pointer. So what would the scale factor? What would the size of a pointer would be? In the case of integers, it would be 4. In the case of double, it would be 8. And in the case of character, it would be 1. So here you can see the trend that the size of a pointer of a pointer to a variable depends upon the type of a variable which we have defined. So this is rather simple to memorize. If you know how many bytes a variable takes in the memory, you can tell, you are able to tell how much memory a pointer of that type would also take in the memory. So that is simple. The size of the pointer var is 4 bytes or 8 bytes, as it unsigned int with the scale factor of the size of the type of the pointer. So if we are just declaring pointer var, it would actually be equal to 4 bytes or 8 bytes if it was an integer or double. For example, if we are to go over the examples, character pointers are 1 byte, short is 2 byte, float int are 4 bytes, and doubles are 8 bytes. Now here I have a small question for you people. What would be the scale factor, or what would be the size of a Boolean type of a pointer? So the Boolean type of a pointer would have 1 byte, because the Boolean itself takes 1 byte in the memory. So it gives the number of bytes to be read while referencing the pointer. So this is all coming together because you can see, if we had an integer, for example, an integer takes 1 byte, 2 byte, 3 byte and 4 bytes. If the pointer was of 3 bytes, if the int pointer took 3 bytes, then it would only be able to read 3 bytes, and then it would not get the exact value of 4. If it was able to read 6 bytes, then it would have something other than these 4 bytes as well. Then it would also not able to get the correct value. So this is the reason why int pointer is equal to int pointer size is equal to int size, because we want to read only those relevant bytes in the memory which the variable is using. If the variable is using 4 bytes, we want to only read those 4 bytes. That is it for pointers in this subject, computer programming with the course score 6900. I thank you for listening to the lecture. Hope you were able to understand it. Thank you. Allah.